All right, welcome back everybody with rotational motion. Today we are talking about the parallel axis theorem. Okay, a little bit maybe not as fun, but it's a little short topic that we're doing. Okay, so if the moment of inertia about the center of mass of a rigid body is known, the inertia at any other axis of rotation of the body can be calculated by the parallel axis theorem. So, for example, we have the cylinder, right? And let's say it's going through this cylinder in the middle. What that means is, and we know the center of mass of the cylinder. I believe it's 1/2 mr squared. If you do that, you can find it, let's say like, okay, the axis of rotation isn't going to be directly in the middle, but we're going to put it all the way to the side. Now, as you can imagine, it's going to rotate differently, or the inertia of the rotation is going to be differently if it's all the way at the side. It's going to be harder to rotate. And there's a formula for this to help you figure out what that inertia is. So that's called the parallel axis theorem. So the inertia is going to be equal to the inertia at the center of mass plus the mass from the distance from the center squared. Okay, so that's how it's going to look. And then what we have is we have a formula for this that's going to look like this. Okay, and we'll do a few more questions with this. This is just a simple example over here. We have the inertia, and then the inertia of the center of mass, which is 1/2 mr squared. That's for a cylinder, solid cylinder. And then we can see this is in a distance r away. So that means this d is just going to be replaced by r. And then we just add it all together. So the inertia is 3/2 mr squared. So the inertia of this one here is 3/2 mr squared, while the inertia of this one, where it's through the center, is just 1/2 mr squared. Okay? And we'll do a few examples of these just to make it make more sense. All right, so here we go. Calculate the inertia of a solid sphere rotating along the outer rim of its body. So we know through the center, it is equal to 2/5 mr squared. But now we don't want it rotating through its center. We want it rotating through all the way through the outside of it. So going around like that. Okay? All right, so let's do this. The inertia is going to be equal to the inertia of the center of mass plus the mass times how far the new axis is from the center squared. Okay, so inertia of the center of mass is 2/5 mr squared plus the mass of the sphere and how far it is from the center. Well, since it's all the way towards the edge, it's just going to be r. So r squared. So how are we going to do this? This is going to be equal to 7/5 mr squared. Okay. Hope that made sense. Moving on. Okay, so calculate the inertia of a rod rotating along the end of the rod. It's kind of like a door almost. It's like something when it rotates along the end, it's kind of like a door. And rotating 1/4 its length. 1/4. Okay, and then that means this is 3/4. Okay, so let's do part A. We know that we should know the inertia of it is going to be the inertia of the center of mass of the rod plus the mass of the rod times how far it is from the center of the rod. This being the center. Okay. So inertia of the center of mass, we know that is 1/12 ml squared plus the mass. And how far is it from the center? This is going to be, r is going to be equal to 1/2 L squared. So let's simplify this further. 1/12 ml squared plus 1/4 ml squared. So this is going to be equal to 1/4 is the same as 3/12. 1/4, right? Yeah, 3/12. Right? 5 by 3, yeah, okay. And then we can have this equal to be 4/12 ml squared. That's going to be at the end, or 1/3 ml squared. Okay. That's for part A. Part B now we're going to do a little bit differently. Let me erase everything. It says, what is the inertia going to be rotating along 1/4 its length of the rod? Okay, but the same kind of process. Try it again. Try it on your own if you feel like you can, and it always just helps even if you can't. Plus mr squared. So we know the center is the same, 1/12 ml squared. Plus mass. And the r, now it's going to be a little bit different. So this is half. So that means how far is it from that center point? It's going to be another 1/4. Okay. So we can put this r as 1/4 L squared. So let's simplify. 1/2. Oh, no, not 1/2. 1/12 ml squared plus 1/16 ml squared. It's going to equal, it's a lot. Maybe, what are we doing here? 48, 24. Okay, so 4 out of 48 ml squared plus 32, 3 out of 48 ml squared. So we have 7 out of 48 ml squared. Okay. All right, I hope that made sense. I'm sure it was a little bit confusing, but kind of watch it again. It takes a little while to get used to, but it's not really that hard. So maybe, yeah, it's not as hard as it looks. All right, with that being said, next time we're going to be talking a little bit more about work and how that works rotationally. Thanks for watching, everyone. Bye.